Welcome, fellow explorers of the cosmos, to a journey through the annals of scientific history. Today, we're about to unravel the most incredible episodes when science got it wrong, only to emerge wiser and more enlightened. From ancient philosophers to modern visionaries, these tales of fallibility and resilience have sculpted our understanding of the universe. Our first stop is the geocentric model of the universe. For centuries, this theory dominated human understanding of the cosmos, with Earth reigning supreme at the center of all things. The geocentric model of the universe is one of the oldest theories in astronomy. It was the belief that the Earth is at the center of the universe and that every heavenly body, including the Sun, Moon, and other planets, revolve around our world. In actuality, this is true for the Moon but not for the Sun and other heavenly bodies out there. The theory was first proposed by the ancient Greek philosopher Anaximander in the 6th century BC. Anaximander claimed that the Earth is a cylinder and that every heavenly body revolves around it. Plato, Pythagoras, and Aristotle later confirmed that the Earth is a sphere but still held that it's the center of the universe. Several astronomers challenged the geocentric model of the universe over the years, especially between the 10th and 12th centuries, but none were accepted as correct. This changed in the 16th century when Nicolaus Copernicus claimed that the Earth is not at the center of the universe. Copernicus wrote his findings in his book, De Revolutionibus Orbium Celestium, on the revolutions of the heavenly spheres. He knew the book would be controversial and only sent it to be published when he was near death. In the late 19th century, scientists were captivated by the notion of luminiferous ether, a mysterious substance believed to fill the vacuum of space. This ethereal medium was thought to be the carrier of light waves, enabling them to traverse the vast cosmos. But was it real, or just a trick of the mind? Let's dive into the story. In the 1880s, renowned physicists Albert Michelson and Edward Morley sought to measure the motion of the Earth through the ether with their famous Michelson-Morley experiment. In the 1880s, renowned physicists Albert Michelson and Edward Morley sought to measure the motion of the Earth through the ether with their famous Michelson-Morley experiment. However, the surprising results showed that the speed of light remained constant in all directions, despite the Earth's movement. This anomaly paved the way for a groundbreaking revelation. It was none other than Albert Einstein who resolved this enigma with his theory of special relativity. Einstein's brilliant work demonstrated that the speed of light is an absolute constant, regardless of one's perspective, effectively dispelling the existence of luminiferous ether. In the late 18th century, scientists were embroiled in a debate over the existence of caloric, a theoretical fluid that was believed to be the carrier of heat. Could this invisible substance be the key to understanding the mysteries of temperature and heat transfer? This novel theory, known as the caloric fluid theory, was at the heart of a scientific dispute for decades. Pioneered by scientists such as Antoine Lavoisier and Joseph Black, it argued that heat was transferred via the motion of this mysterious, caloric fluid. However, the theory faced a transformative challenge with the emergence of the kinetic theory of gases in the 19th century. Visionaries like James Clerk Maxwell and Ludwig Boltzmann provided a compelling alternative, by explaining heat transfer in terms of the movement of particles. The final blow to the caloric fluid theory came with the groundbreaking work of James Joule. He demonstrated the mechanical equivalent of heat and showed that heat is a form of energy rather than a substance. With this, the long-standing debate finally settled in favor of the kinetic theory of heat. Albert Einstein, renowned for his theory of relativity, had a vision of the universe that was intriguingly unchanging. He envisioned a cosmos that remained static and eternal, devoid of expansion or contraction. Einstein's theory had an impact on the cosmological landscape of his time. In 1917, he introduced the cosmological constant into his equations to counteract the effects of gravity and achieve a stable, unchanging universe. However, Einstein's vision of a stationary cosmos soon faced a significant hurdle. Observations by astronomers, most notably by Edwin Hubble in the 1920s, revealed that the universe was, in fact, expanding. The concept of an expanding universe contradicted Einstein's static universe. As a result, he famously referred to the introduction of the cosmological constant as his greatest blunder. Einstein's original vision of a static universe eventually gave way to the ever-expanding universe, which is one of the cornerstones of modern cosmology. This monumental shift in perspective opened the doors to new insights and discoveries about the cosmos. In the annals of medical history, the miasma theory stands as a testament to the evolving understanding of disease. During the 19th century and earlier, the miasma theory held sway in explaining the spread of infectious diseases. At its core, the miasma theory proposed that diseases like cholera, the plague, and others were spread through bad air or miasma, generated by decaying organic matter, foul odors, and unsanitary conditions. Medical professionals of the time, unaware of microscopic pathogens, believed in the harmful effects of these invisible noxious fumes on human health. In their efforts to prevent illness, they turned to practices like burning aromatic substances and isolating those afflicted. While the miasma theory did encourage improvements in public sanitation, it was fundamentally flawed. It couldn't explain outbreaks in well-ventilated areas or the role of microorganisms in causing disease. In the late 19th and early 20th centuries, Mars captured the imagination of astronomers and the public alike. At the heart of this fascination lay a mystery, what appeared to be a network of canals on the Martian surface. Prominent figures like Giovanni Schiaparelli and Percival Lowell reported observing these intricate lines crisscrossing the planet's face. These observations kindled speculation of advanced civilizations and intricate irrigation systems on Mars. However, as technology improved and space exploration became a reality, these canals gradually vanished from the map. The advent of telescopes with higher resolution and spacecraft missions unveiled Mars' real face, a barren and desolate landscape. It's a stark example of how observation tools and scientific understanding can reshape our perceptions of other worlds. While the Martian canals have faded into myth, they left an enduring mark on the journey of space exploration. Thank you for joining us on this captivating journey through the annals of scientific history, exploring moments when science took an unexpected turn. As we reflect on these historical shifts in scientific thought, it's a testament to our collective pursuit of knowledge and our willingness to embrace change. If you've enjoyed this video, don't forget to like and share it with fellow science enthusiasts. Subscribe to our channel for more exciting explorations of science, history, and the wonders of the universe. We'll be back with more thought-provoking content, so stay curious and keep exploring. Until next time.